All right, guys, if you would please grab out your Organizing and Analyzing Outcomes student guide. And we're going to go and walk through this together. All right, so your teacher will assign you the following scenarios to complete. So you guys, some of you guys will have the cards and some of you guys will just see the screen or just see your paper, which both of those can be used in the exact same concept. So I'm asked to list, so I'm given the cards 1, 2, 3, 4, 5, and 6. I am asked to list all the possible outcomes when a card is drawn, replaced, then another card is drawn. So for example, if I draw 1, so I pick up the card 1, if I put it back down, I want to know what are all the possible outcomes I could get on the second pick. Well, I could get a 1, I could get a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, and a 1 and a 6. So if I draw 1 the first time, replace it, is there any other possible outcomes I could get? No. All right, well, what if I draw a 2 the first time? I could get a 2, 1. If I replace it, I can get a 2, 2, a 2, 3, a 2, 4, 2, 5, or a 2, 6. I'm going to draw a 3 the first time. I can get a 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. I could draw a 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and a 4, 6. I could draw a 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, or a 5, 6. Then I could draw a 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, or a 6, 6. Okay, so how many outcomes did we come up with? Well, I have 6 in each column, and then I have 6 rows, so I should have a total of 36 outcomes in all. Well, what if I told you that I was going to draw one card and I'm not going to replace it? What possible cards could I draw now? So if I draw a 1, well, that takes away the 1. So I can't draw a 1 again. I'm not replacing it. I could get a 1, 2, a 1, 3, a 1, 4, 1, 5, and a 1, 6. Okay. What if I drew a 2? Well, 2, 1, 2, 3, 2, 4, 2, 5, and 2, 6. Okay. What if my first draw was a 3? I have 3, 1, 3, 2, 3, 3, 3, 4, or, oh, nope, not 3, 3. Oops, 3, 4, 3, 5, and 3, 6. I can't have a 3, 3 because I picked up the 3 and I didn't put them back down. Okay, what if I picked up a 4? 4, 1, 4, 2, 4, 3, 4, 5, and a 4, 6. I could have a 5, 1, 5, 2, 5, 3, 5, 4, and a 5, 6. I could get a 6, 1, 6, 2, 6, 3, 6, 4, or a 6, 5. I have 5 in each column and I have 6 rows, so I have a total of 30 outcomes. So how are these two scenarios different? Well, the first time we drew one card and replaced it, giving us a chance to draw that card again. On the second time, we drew one card and did not replace it, making that card impossible for us to draw again. All right. So what strategies did you use to organize your list of outcomes? Well, we used an organized list and created all possible outcomes. Okay, Then it's saying which side of the room had to list more of the outcomes. Well, if we were in the class and doing this as a group, the side of the room that would have had the most outcomes would have been the ones who replaced the card. Would be the ones who had to replace their card. Okay? So how did you know that your list was complete? Meaning, how did you know that you have listed all of your outcomes? Okay? When looking and holding our drawn card, we noticed we did not have any other cards left for outcomes. Okay? Meaning if you were actually playing this game, if you picked up card number 1, if you're in the not replace group, so card number 1 is gone. So the only options that you have left are picking a 2, a 3, a 4, a 5, or a 6. And looking at it and noticing that you have no other option left, meaning you have completed all of your outcomes for drawing 1 the first time. Then you're going to replace 1 and you're going to say, okay, what if I drew 2 the first time? Then you're going to look at everything that you have left and you only have 1, 3, 5, 4, and 6 that are left. Okay? 1, 3, 5, 4, and 6 that are left. All right. So let's take a look. So if you roll a dice twice, which statement is this like? All right. So I think what I need to do is I need to show you guys a PowerPoint. Oh, never mind. It's saying if you roll a dice, which situation is this like? So if I'm taking a dice and I'm rolling it, and I'm rolling the dice 2 different times, I have 1 set of dice, which situation would it be looking like a replacement or a not replacement? And it is similar to our replacement situation. There is also a PowerPoint for you guys watching the video that if you look on Google Classroom, you can go through the PowerPoint as well. That'll help you. Okay, I'm just going through this on paper here. All right. So which situation is represented in the array below? Well, if you look at your paper, it's not going to be highlighted, but I'm going to take care of that for you. And it is showing everything in column 5 is highlighted. And then everything in column 3 is highlighted. And it's asking us, which situation is this like? Okay. Is this like us drawing a card and then replacing it? Or is this like us drawing a card and then not replacing it? So if I take a look, if I drew the 5, I could have 5, 1, 5, 2, 5, 3, 5, 4. Well, look, I have 5, 5, and then 5, 6. Well, wait a minute. So if I drew the 5, I can have the 5. Okay, so this situation is similar to our replacing activity. It's similar to our replacing activity. All right. So it's asking us, what is the probability? Okay. What is the probability of drawing a 3 on the first card? Highlight that row. All right. So we've highlighted row 3, and I want to know, what is the probability of drawing a 3 on the first card? Well, I have 1, 2, 3, 4, 5, 6. I have 6 out of, I have a total of 36 outcomes, which can get me to 1 out of 6. Okay, 1 out of 6. All right. What is the probability of drawing a 5 on the second card? So I'm just asking for 5 on the second. So I have 1, 2, 3, 4, 5, 6. We'll have a 6 out of 36 chance of getting a 5, which can reduce down to 1 out of 6. Okay. So it's asking, what is the probability of drawing a 3, replacing it, and then drawing a 5? Okay, so what is the probability of drawing a 3 on the first one, replacing it, and then drawing a 5? All right, so I've got my 3 column highlighted, and I have my 5 column highlighted. Okay. So I drew a 3 the first time. Okay. And I replaced it. I want to know what's the probability that I'm going to get a 5. So I'm going to have a 3. Where is it? 3, 5. Well, the only chance of having a 3, 5 is this one individual cell. So it's 1 out of the total of 36 possible outcomes. 1 out of the total 36 possible outcomes. Okay. So what's now the probability that you're going to draw a 1, replace it, and then draw a 1 again? So I'm drawing a 1 the first time, replace it, and I'm going to pick up a 1 again. Well, I only have one opportunity, and that's in this top cell up here, of 1 out of 36 total chances. Okay. What's the probability of drawing a 1, not replacing it, and then drawing a 1 again? Well, okay, so I drew a 1 the first time. Well, if I draw a 1 the first time, I can't draw a 1 the second. I'm not replacing that 1 card. So I have a 0 out of 36 possibility of drawing a 1 the second time. All right. Number 12. What is the probability of drawing an even number, replacing it, and then drawing another even number? Okay, so we're going to draw an even, replace it, and then drawing another even. Give me 2 seconds. All right. So the probability of drawing an even number on the first time, I have 1, 2, 3 out of 6 chance. Replacing it and then drawing another even, well, I have 1, 2, 3 possible chance. So 3 out of 6. Okay. So I have a 3 out of 6 the first time, a 3 out of 6 the second time. I'm replacing it and then, keyword and. So I'm going to multiply 3 times 3, which is 9, out of 6 times 6, which is 36. So you have a 9 out of 36 chance, or you can reduce this down to 3 out of 12, which can go down to 1 out of 4. Okay. All right. What is the probability of drawing an even number? Okay, so we know an even number the first time, not replacing it, and then drawing another even. So I'm going to multiply again. So I'm drawing an even number. So let's suppose I draw a 2. Okay, so I have a 3 out of 6 chance of drawing a 2. Well, if I draw a 2, everything in my 2 column goes away. So I'm left, there you go. So I'm left with 5 cards that I could draw again. How many of those are going to be even? Well, 4 and 6 are the only even choices after that. So you have a 2 out of 5 chance to draw an even. So 3 times 2, which is 6, 6 times 5, which is 30. So you have a 6 out of 30 probability to draw an even, not replace it, then another even, which this can reduce by 6 down to 1/5. It can reduce by 6 down to 1/5. All right. All right. So let's take a moment and process your comprehension of probability with replacement and without replacement. Okay. So when looking at with replacement, you have the same probability. Without replacement, you take away an entire chance of something happening. Okay, so you're going to take away that entire chance of something happening or going on. Okay. All right. So what is the probability of taking a red marble, not replacing it, and then taking a blue marble? All right, so I'm going to take a red marble, not replace it, and then grab a blue marble. All right, so let's go ahead and let's make our organized list, or let's actually make a tree diagram. I think that'll be a little bit easier. Or organized list. Which one do we feel like today? Let's do a tree diagram. All right, so I'm going to start with my star. Okay. Now, on the first time of me drawing a color out of my bag, I could receive R, and I'm going to label it R1 because I have 3 R colors and 2 blue colors. So I'm going to start labeling it R1, R2, R3, blue 1, and blue 2. So I can see what's going on. So I could draw R1 the first time. I could draw R2 the first time. I could draw an R3 the first time. I could draw a blue 1, or I could draw a blue 2 the first time. Okay, so I'm going to draw a red marble, not replace it, and then draw a blue marble. Okay, so we're making a tree as far as if we draw this marble. So if I draw red 1, I'm not going to replace it, and I want to know what can I draw left. Well, I can draw an R2, R3, blue 1, and a blue 2. Okay, what if I drew R2 the first time? Well, you can get a R1, R3, blue 1, or blue 2. You cannot get an R2 because you drew it, didn't replace it, and you drew a second marble. Now, for R3, you can get an R1, R2, B1, or B2. For blue 1, I'm going to have to go all the way down here. You can get an R1, R2, R3, or a B2. What if I chose the second blue marble? What can I get? So I'm going to go over here off to the side. I can get a red 1, a red 2, a red 3, or my first blue marble. Okay. Now, let's go ahead and use our tree to create our organized list. So I can get an R1 or an R2, R1 and R3, R1, B1, R1, B2. Okay, so I just created an organized list from my first tree branch. Okay, let's try the second one together. R2, R1. R2, R3, R2, B1, R2, B2. Okay, pause the video and take a moment, and I want you to create your organized list for the next 3 branches, please. R3, R1, R3, R2, R3, B1, R3, B2, B1, R1, B1, R2, B1, R3, B1, B2, B2, R1, B2, R2, B2, R3, B2, B1. There's only 3 R's. All right. So all of this will help us. So you can either do the tree or you can do the organized list. Okay. I prefer the tree at some points because I think it's easier to visualize. And then here's an organized list for those of you that like this. So I want to know, what is the probability that I get a red marble first? So this is happening first. So I pick out a red marble first. I do not replace it, and then I take out a blue marble second. Okay, so I want red, then blue. All right, so I've got red, 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 red. Oh, I've got a red, blue, red, blue. I have a red, blue, red, blue, red, 3, 1, red, 3, blue, 2. And these are all blue first. These are all blue first. So how many outcomes did we circle where we got red first, then a blue? Well, we received 6 outcomes that we want out of 1, 2, 3, 4 in each column. And I have 1, 2, 3, 4, 5. So I have 20 outcomes. So 6 out of the 20 have red first, then a blue, while not replacing it. And this can be simplified down to, I think it's what, divided by 2, you get 3 over 10. And you get a 3 out of 10 chance. All right, let's try it again. Number 2, you draw a green. What is the probability of choosing a green book, not replacing it, and then drawing a yellow? So green is first, then yellow is second. Okay, so picture we have 1 red, 1 yellow, 1 blue, 1 green, 1 brown. Okay, so let's go ahead and make an organized list of all the possibilities that we can get of drawing a book, not replacing it, and then drawing the next. So if I draw a red, can I get a red the second time? Oh, wait, no, this is replacing it. Sorry, this is replacing it. So I can draw a red, red. I can draw a red, yellow, red, blue, red, green, a red, brown. I didn't read it. I need to read replace. All right, I can get a yellow, red. Oops. Yellow, 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 blue, yellow, green, yellow, brown. You can get a blue, red, blue, yellow, blue, 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 green, or a blue, brown. Okay, let's do BR. I forgot there was 2 B's. What is it? Green? Okay. Green, red, green, yellow, green, blue, green, green, or green, brown. Then I can have brown, red, brown, yellow, brown, blue, brown, green, brown, brown. Okay, I've created my entire organized list. Okay, so I want to know, what is all of the probability of choosing a green book first? Okay, well, I can have this entire column here of choosing green first. Okay, so now I replace it. Then I want to know, what's the probability that I'm going to choose a yellow the second time? Well, drawing yellow the second time is this entire row here. Okay, so our question is saying, I want a green book first, then a yellow. Well, green first, then yellow is a 1 out of 1, 2, 3, 4, 5 in each column. 1, 2, 3, 4, 5 columns. out of 25. You have a 1 out of 25 chance of getting a green, then a yellow. Okay? Well, let's look at the probability again. And this time, Ms. Brown's going to read, and we're going to not replace our books. So I want a green first, then a yellow the second time. And I do not want to replace anything, which means any of my double colors, they're going to go away. So you could get a red, yellow, red, blue, red, green, red, brown. You can have a yellow, red. I don't have a yellow, yellow. I can have a yellow, blue, yellow, green, yellow, brown. You can have a blue, red, a blue, yellow. I cannot have a blue, blue, but I can have a blue, green, or a blue, brown. I can get a green, red, green, yellow, green, blue. You cannot get green, green because we're not replacing it. So green, brown, brown, red, brown, yellow, brown, blue, brown, green. I cannot get a brown, brown because if I pick up a brown book, not put it back, I can't get the brown book again. So I want to find the possibility of getting green, then yellow. So I'm going to find my green stack and then my yellow. And I have a 1 out of, well, I have now 1, 2, 3, 4 in each column and 1, 2, 3, 4, 5 rows. So I now have a 1 out of 20th chance to get a green first, then a brown. Okay. All right. Number 4. Sorry, there we go. All right. There are only 4 slices of pizza left at the school. We have cheese, onion, pepperoni, and sausage. Lisa is buying 2 pieces. What are the possible combinations he could get? All right, so what probability do you think this sounds like? So there are only 4 slices left. There is 1 cheese, 1 onion, 1 pepperoni, and 1 sausage. So do you think we're going to get, if I pick up a cheese, do you think I can get a cheese again? No, I can't. So do you think this is going to be a replacement problem or a not replacement problem? Well, this sounds like a not replacement problem to me. So let's see. I could get a cheese onion, cheese pepperoni, or a cheese sausage. I can get an onion and a cheese, onion and pepperoni, onion and sausage. I can get a pepperoni cheese, pepperoni onion, and a pepperoni and a sausage. I can get a sausage and a cheese, sausage and an onion, and a sausage and a pepperoni. Okay? There are no other combinations I can get. So how many outcomes do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 6. So you have 12 total outcomes. Okay, I have 12 total outcomes. So what is the probability that we draw a cheese, then a sausage? So cheese and then sausage. So I'm going to look at this. I see I can get a cheese and a sausage, 1 out of 12 possible outcome. What about an onion, then onion and then a cheese? So onion and cheese, you have a 1 out of 12 chance. What about an onion and then another onion? Well, wait a minute. If I pick up my onion, I only have a cheese, pepperoni, and sausage left. I don't have a second onion pizza. So is this possible to happen? No, this is a 0 out of 12 chance. It's impossible to happen. Okay? It's impossible to happen. All right. What about 1 slice will be sausage? No matter what, one of them is going to be sausage. So we're going to go back to our list and we're going to circle everything that I can get a sausage in. Well, I can get a cheese sausage, onion sausage, pepperoni sausage. I can also get a sausage cheese, sausage onion, and a sausage pepperoni. So I have a 1, 2, 3, 4, 5, 6. I have a 6 out of 12 chance, which reduces to 1/2. I have a 1/2 probability that I'm going to pick up a sausage pizza. A 1/2 probability that I'm going to pick up a sausage pizza. All right. What is the probability that you will take a green cube, not replace it, and then taking a red cube? All right. So a green cube, not replace it, and then taking a red cube. Okay. Well, we're going to go back to this problem right here. When I said an even number, not replace it, and then drawing another even number. So remember when I had a 3 out of 6 chance to get an even? Yeah. And then I did not replace it. And then I went and I was like, okay, what about if I get a not even chance? Okay. So that's what we're going to do. So if I pick up a green cube, okay, I have a 1 out of 3 chance of getting a green cube. Okay. If I do not replace this green cube, I now have a 1 out of 2 chances to get a red cube. And I'm going to take my probabilities and I'm going to multiply them. So I see 1 times 1 is going to be 1. 3 times 2 is going to be 6. So I should have a 1 out of 6 chance to get a green first, then a red. If you have any questions, please let us